So if we're going to be able to use the features of the standard normal distribution, those Z scores, to make inferences about every other normal distribution that we care to look at, we need some way of calculating the Z score for any piece of raw data. Now, a Z score tells you just how many standard deviations any value is from the mean. Then once we have our Z score for any piece of raw data, then we've got an idea of what the likelihood is of that value actually occurring in its own distribution. So why would we want to do this? Well, it means that instead of doing that difficult integration with lots and lots of different curves, we can just look at it once. Now, even the standard normal distribution is difficult to integrate, and it goes beyond the integration skills that we've learnt in this course. So there's a few ways around that. You can either use statistical software that calculates the areas for you, or what we're going to do is the old-fashioned way. You look up scores in tables, and this gives you a really good estimation for how common or how likely each score is to occur given how far away it is from the mean. And remember that things that are close to the mean are very likely to occur, and things that are far from the mean are unusual. So by their very nature, they're unlikely to occur. All right, so let's calculate some Z scores. Now, the formula for calculating these is actually on your reference sheet. So you don't need to memorize this, but you do need to know how to find it and how to apply it. I find it easier, rather than memorizing this formula, just to consider every time what it really means. A Z score tells you how many standard deviations above or below the mean a score is. So let's have a look. We take a score, X, we subtract the mean to see how far away it is from the mean, and that will give us an idea of whether it's above or below based on whether it's a negative number or a positive number. And then we divide by the standard deviation to see how many standard deviations that would be. So let's look at an example here. In a maths test with normally distributed scores, so that's important. If they're not normally distributed, you can't go finding Z scores. Won't make any sense. The mean for this test is 60%, and the standard deviation is 10%. Now, we have to convert scores of 90%, 50%, and 76% to Z scores. So I literally just think of it as this. 90%, how far above or below the mean is that? Well, it's 30% above, isn't it? And how many standard deviations would 30 be? Well, 30 is 3 lots of 10. So it's actually 3 standard deviations above the mean. So I can actually just look at this and in my head say, that's a Z score of 3. Okay. Now, if you want to apply your formula, go ahead. You would be going 90 minus 60 divided by 10. But if it's nice simple numbers, you can literally think that through as quickly and easily as you can look up the formula and apply it. And as I said, it's really important to understand what it is that you're doing. All right, a score of 50%, is that above or below 60%? It's below, isn't it? So if we did 50 minus 60, we'd get minus 10. And if we divide minus 10 by 10, we get negative 1. So this one has a Z score of minus 1. Now let's stop for a minute and think about what that means. What this means is that the person who got 90% in this test, they are 3 standard deviations above the average. So think about what that looks like on the standard normal distribution. It's right up in that high tail, isn't it? Which tells you it's very uncommon, and probably not many people got a score that high in this test. If more people had have, the standard deviation would have been higher. So by its very nature, this is an unlikely score, a Z score of 3. A Z score of minus 1 tells us that we are 1 standard deviation below the mean. And remember, that was the point where there is a point of inflection in our standard normal distribution. So it's right at that point where things start to be not quite as common. This is the area here where most of the scores would be, between 1 and minus 1. And we're sort of on the edge of that. All right, what about a score of 76%? Well, 76 minus 60, that gives us 16. And when we divide 16 by 10, I can do that in my head, we get a Z score of 1.6. Now, 1.6 is positive. That tells us that it is above the mean. How far? Well, a little bit further than that point of inflection that's at 1. It's more like here. So that's starting to be quite a high score, not super common. that person's done quite well in this test.